The next operators that we're going to look at are called as the bitwise operators, where we are going to handle each number as bits, and each of the bits of the numbers are going to be modified or controlled. So let's say, for example, we have a is equal to 6 and we have b is equal to 4, and we say a and b. What happens now? Just to tell you all, what is the binary of a? Binary of a can be written as 6, right? 0000. It's an 8-bit binary. So, and after that it can be written as 0110. So this is your a, and this is your b. B is hash 0000 This is your b. So now, can you tell me, when you do an AND, you're going to do a bitwise AND, which means this 0 is going to be ANDed with this 0. This 0 is going to be ANDed with this one. This one is going to be ANDed with this one. So what is going to be the answer? What is going to be the answer? The answer is going to be, if I'm going to actually AND each of them, so the first 0 and 0 is a 0. The second 0 and 0, 0, 0, 0, 0. And 1 and 1 is 1. 1 and 0 is 0. 0 and 0 is 0. So the answer is 4. Hope you understand how you do an AND. So if I do an A OR with 6, A OR with B, okay, and I say answer is 6. So 4 or 6, the answer is 6. Okay, so that means it does an OR between these two numbers. 0 OR with 0, a bitwise OR, is a 0. 1 OR with a 0 is 1. 1 OR with a 1 is 1. 0 OR with 0, 0, 0, 0, 0, 0, and so on. So you have an A or B is a 6. Is there any other bitwise operator which is there? Okay, we can think of another bitwise operator. Maybe we can have something like this: A XOR with B. What is A XOR B? Which means when I have 0 and 0 XORed with each other, 0 and 0 XORed with each other is 0. 1 and 0 XORed with each other is 1. 1 and 1 XORed with each other is 0. So XOR is a combination which detects an odd number of ones. So that means if you have a 1 and a 1, the answer will be 0. If you have a 0 and a 0, the answer will be 0. But if you have a 1 and a 0 or a 0 and a 1 XORed with each other, then you have something, the answer is going to be 1. So XOR, a bitwise XOR, is going to do this particular operation of XORing the bits one after the other. Okay, are there any other bitwise operators? There are. Okay, there is an operator where you say A, I want to left shift by 2. I want to left shift by 2, which means it says, okay, it's 24. What is A? This is your A. Left shift by 2 means I'm going to shift all the bits by 2, which means this 0 will go out altogether. So basically this 0 will come here, this 1 will come here, this one, that is left shifting by 1. But what if when I left shift by 2, these two ones will left shift by 2, which means they both will come here. Okay, and these all will be zeros. So 0, 0, 0, 1, 1, and 0, 0, 0. So that is 16 plus, I'm so sorry, 8 plus 16, and that is 24. Is that understood? 1 here is 8. It's in the weightage of 8, and this is the weightage of 16. 16 plus 8, that is 24. Sir, what if I do A right shift by 2? A right shift by 2. Answer is going to be a 1. This one is, when I right shift by 2, these two ones are going to go 2 places that side. This one is going to escape altogether. This one is going to remain over here. So you're going to have a 1. So this is what the right shift operator does, and a left shift operator. We just had a look at each of them. Okay. So these are a few bitwise operators which we must think of. Okay. Two more kinds of operators which we might have to remember. So the above one, it was called as the bitwise operators. Another operator is called as a membership operator. What does membership operator say? Say, for example, I define a string. Let's say the string is, hi, how are you? Okay, this is your string. And if that is your string and that is your S, I want to see if there is a question mark in S. I want to see if there is a question mark in X, in S. How is it possible for me to see that? Let me say I'm going to define a character C, which is again going to be a smaller string, and that I'm going to say is a question mark. If it is a question mark and I say enter, and I say C in S, C in S, if I say C in S, it says true. Yes, the question mark is there. Okay, so C not in S, not in S, which means false. No, no, no. When you say C not in S, it is not, it is not true, it is false. So hope you understand what a membership operator means. A membership operator checks whether one element is there in a bigger element. This element or this string is there in another bigger string. Hope you understand that. That's a membership operator. Finally, we come to the last operator where we can call it as the is operator. Is operator. What does this is operator do? Okay, this is a very this is an operator. Say for example, I need to come up with this. I hope I've explained this in the first lecture itself, but I had told you that if a is equal to 12 and if I say b is equal to 12, okay, and I said if you want you can find out the id of a and you can find out the id of b, you can find out the id of b. Okay, both of them are having the same ids, which means in python, a and b are two objects pointing to the a and b are two instances, two variables pointing to the same object, that is 12, that is created from the int class. Yes or no? Okay, so class int. So that means both of them are pointing to the same address, which means even though two different objects were created, or we thought two different objects were created, no, 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 only one object was created and a was pointing to that object and b was pointing to the same object. Hope you understand that. Sir, is it so? Then if I want to compare the addresses of both, if I want to compare the addresses of both, I will say, you will say, okay, can I not compare with a equal to b? Okay, but a equal to b is a comparison by value. It compares by value. Okay, it does not compare by the address. But if I say a is b, it says true, which means it compares the address and says, okay, both these addresses do match with each other. So a is b is a comparison by address or a comparison by id. Okay,